If this problem feels like a recap, that's a good thing. We're in the 2.4 already. We are making a multiplicative, aka geometric, aka exponential pattern appear with only a few terms given. We're filling in the missing values on the table and writing an explicit equation for the pattern. Wonderful. Let's start with problem one. Starting with 2, it's eventually going to aim for 64, but there are a lot of gaps in between. So let's see exactly how many gaps there are. Starting with 2, we would multiply by some number x here. We have this again here as well. So there's 2 here again. That's another hop. So a third x, a fourth x, and you've guessed it, 5x. So what does this mean? This means that starting at 2, we keep multiplying by x 5 times and eventually get 64. How do you think we could go about isolating x in this case? Any guesses? Any takers? Hopefully you're saying divide by 2 to try and isolate x to the 5th. So if we take this further, x to the 5th is on its own. That leaves us 64 divided by 2, which is 32. And so to get rid of this exponent of 5, we can take what's called a 5th root. We can do that here. We can do that here. If you're curious what that spelling is like, this is what I'm saying. We're taking a 5th root, similar to a square root, but shot in the dark. Why do you think it's called 5th root? Well, because this little 5 is kind of tucked away in the elbow. That's here. We'll see how we can take a look at this on a calculator. So I'll hand you the answer. It's definitely going to be, if we take the 5th root of 32, the answer is 2. That'll help us in a second. If you're knocking this out on a calculator, or maybe you have problems that are a little bit more challenging, we'll take a look at how we can get those radicals on our calculator. So if we hit second, it's like back out. Let's hit second, catalog. We're going to hit up a bunch until we hit this right here. We're taking the 5th root of 32. So 32 goes inside. Boom. Done. There's 2. You might have also noticed how I got this option seen here, where if we rewrite the radical, since it's just 32 to the 1st power, we can play that out and say we still want 32, but we want an exponent. Since 32 was to the 1st power, rewrite 1, but then in this exponent, we say we divide by 5 because we're taking a 5th root. You can hit enter again. Lo and behold, our answer here is 2. So this is a little detour way, hopefully a quick way for you to get square roots and cubic roots and quartic roots if need be, if you have your calculator on hand. So we can now hop back here and say that every time we move forward 1 term, so notice we keep popping ahead just 1 term. Every time we move ahead 1 term, we can multiply by 2. 2 times 2 gets you 4. 4 times 2 gets you 8. 8 times 2 gets you 16. Then 32. A little bit higher up here, but nothing we can't handle. 128. I'll leave you to get the last number. We're also not done. We still need an equation for this. So we've made geometric or exponential equations before. So I'm going to start with my first term of 2. So starting with 2, I keep multiplying by 2. X minus 1 times. There you go. That's our explicit. There it is. Take a moment. Try problem 2. If you think you're good with this stuff, try problem 2. See what you come up with. So if you set up this problem correctly, you should have had 360 times x being cubed equals 45. If you solve for x, you divide by 360, x cubed equals 1/8. So right here, we're taking the cubic root of 1/8, which is a fraction, might intimidate us, so use a calculator if need be. If you follow through, we see that the cubic root of 1/8 is 0.5. So that helps us because now we know either 0.5 or 1/2 is our common ratio. So every time we move forward, we're taking half of the previous term. So let's hop back here. Starting with 360, if we multiply by 1/2, or 0.5 if you're so inclined, that gets us 180. Let's do it again, get us 90. Do it again, get us 45. That makes sense. Half of 45, what is that? 22.5 and 11.25. I'll leave you to get the 7th and 8th term, but we're taking half. So if we hop to the equation, starting at 360, we keep multiplying by 1/2, x minus 1 times. Boom, there we go. Stuck on anything? Let me know. Let's keep going. So same as it ever was, we're now working with fractions now, but that can't stop us. In here, they're saying that the growth in the table is tripled at each whole year. Certain amount of bacteria, we have fractions of a year, that's okay. Same song and dance, honestly. Starting with 2, we multiply by some number once, twice, so x squared times. And the last stop on this train is 6. So if we take this further, divide both sides by 2, divide by 2, we get x squared equals 3. We can take that square root. We talked previously on how we might get plus or minus square root of 3. In this case, bacteria is going to be growing at a positive rate, so I'm just going to keep this as positive 3 for our common ratio. Hope that's okay with you. If we hop to it, keep multiplying by square root of 3. This is 2 square root of 3. Multiply by square root of 3 again gets you to 6. This is now 6 square root of 3. Jumps to 18. 18 square root of 3. Multiply again by that. What's that? 18 times 3, so 50-ish and some change. Let me see. Yep, 54. Boom. Keep multiplying again. 54 square root of 3. All good. Yeah, that's that one. Oh, I should also note that the explicit for this is starting at 2 as the 0 term. We keep multiplying by 3, just x times. It's exponential, so make sure that x is your exponent there. In 10, we see something similar, but now we have more fractions in between. But don't let that stop you. It's seriously the same song and dance, just now with an extra hop. So starting at 2, we keep multiplying by this missing mystery term 3 times. Still equals 6. So now we're claiming that x cubed equals 3. So our new common ratio of sorts is going to be the cubic root of 3. So let's get to it. This is 2 times the cubic root of 3. We can then, and we'll zoom in so we can see a little bit more of this. We just keep multiplying again by square root of 3 with all of these intervals. So you could just leave cubic root of 3. This is 3, but now say that just that radical is being squared. I hope that makes sense. You can keep this going. 6 cubic root of 3. Keep going again. 6 cubic root of 3, but now that's being squared. And this is still going to be 18 with the cubic root of 3. And I'll leave the rest for you. Still the same explicit equation as before, but just more intervals taken out. So don't let that throw you off. You're still starting at 2 and keep multiplying by 3 collectively when you're jumping a whole increment of 1. But that's not the case as we see here. You have to be a little strategic because this is saying that we need to hop a cubic root of 3 every time that we move with these fractions. So I hope this video was helpful. If you have any questions, let me know. Thanks for watching.